Welcome back to our AI series. Today we're focusing on a vital aspect of AI, data. We'll cover the different types of data, how it's processed, and the ethical considerations involved. This video is designed to give you a clear understanding of data's role in AI, regardless of your background. Let's dive in. Now let's delve into the importance of data in artificial intelligence and machine learning. At its core, AI is all about data. It's the fuel that powers the algorithms and the key ingredient that makes learning possible for machines. Data in AI is like experience for humans. Just as we learn and grow from our experiences, AI systems learn and evolve by processing data. It helps them recognize patterns, make predictions, and improve their decision-making over time. In machine learning, data is used to train models. These models, when fed with large and diverse datasets, can perform tasks ranging from simple ones like categorizing emails to complex ones like diagnosing diseases. The quality and quantity of data directly impact the effectiveness of these models. Without data, AI systems cannot learn, and without learning, there is no AI. This is why data is often referred to as the backbone of AI and machine learning. It's not just about having data, it's about having the right data. That's where the real power of AI lies. As we progress, keep in mind that the journey of AI is essentially a journey through data, its collection, processing, and application, all while navigating the ethical landscapes that come with it. But what is exactly data? In the realm of AI and computing, data is essentially information. It's the raw material that we feed into computer systems to inform, train, and improve their algorithms. Data comes in many forms: numbers, text, images, sounds, and more. It represents the facts and figures about the world around us, captured in a format that machines can process. In AI, this data is used to create models that mimic human intelligence. These models learn from data, find patterns, make decisions, and predict outcomes. The more data these models have, the more accurately they can perform tasks and make decisions. Think of data as the language through which we communicate with machines. By providing them with data, we're teaching them about our world, our behaviors, and our needs. This process of learning from data is what enables AI systems to carry out tasks that, until recently, were thought to be exclusively human, like recognizing speech or identifying objects in photos. So in the simplest terms, data in AI and computing is the foundational element that enables machines to learn, grow, and function in an intelligent manner. Let's start by exploring one of the primary types of data used in AI: structured data. Structured data is highly organized and easily understood by computer systems. It's typically stored in databases and spreadsheets, where it is arranged in a fixed format. This format includes columns and rows, making it easy to enter, search, and manipulate. Examples of structured data are things like customer names in a CRM database, transaction amounts in financial records, or temperature readings in a weather dataset. Each piece of information fits into a predefined category and format. For instance, in a database table, you might have columns for customer ID, name, purchase date, and amount. Each row in this table represents a single record, such as a specific transaction. In AI, structured data is crucial because it is straightforward for algorithms to analyze. The clear, organized nature of this data allows AI systems to efficiently process and extract insights, like detecting spending patterns in financial data or predicting customer behavior based on past purchases. So in summary, structured data is essential in AI for its ease of use and the straightforward way it can be processed and analyzed by algorithms. Now let's talk about unstructured data, which is quite different from structured data. Unstructured data is not organized in a predefined manner and doesn't follow a specific format. It encompasses a vast array of information types, including text, images, audio, and video. Imagine the vast amount of data generated on social media platforms: tweets, blog posts, videos, and images. This is all unstructured data. It's rich in information but lacks a uniform format, making it more challenging for traditional data processing systems to interpret and analyze. In the context of AI, unstructured data is incredibly valuable. For instance, natural language processing algorithms use text data to understand and interpret human language. Image recognition systems analyze visual data to identify objects or faces. Audio data is used in voice recognition systems to understand spoken commands. The processing and analysis of unstructured data are more complex than structured data. AI systems need advanced algorithms like deep learning to extract meaningful insights from this diverse and intricate data. Despite these challenges, the insights gained from unstructured data are often more detailed and nuanced, offering a deeper understanding of human behaviors and preferences. In summary, unstructured data is a more complex but exceedingly rich source of information for AI systems, providing a closer look into the varied and dynamic nature of the real world. Next, let's delve into semi-structured data. This type of data sits between structured and unstructured data, possessing qualities of both. Semi-structured data doesn't fit into rigid tables like structured data, but it does have some organizational properties that make it easier to process than completely unstructured data. Common examples of semi-structured data are JSON and XML formats. These data formats are used extensively in web applications and for data exchange between systems. They are flexible and can represent complex hierarchical structures, which is something traditional databases struggle with. In JSON, JavaScript object notation, data is organized into key-value pairs, similar to a dictionary in programming languages. For example, a JSON file might store information about a user with keys like name, email, and age, each paired with corresponding values. XML, extensible markup language, is another format where data is enclosed within tags, which offers a hierarchical structure. It's often used in web services and configurations. For AI and machine learning, semi-structured data is valuable because it combines flexibility with some level of organization. AI algorithms can parse these formats relatively easily, extracting relevant information without the need for the rigid structure of a database. This makes semi-structured data particularly useful for tasks that require a balance between structure and flexibility, such as data from web sources or configuration settings in software applications. In summary, semi-structured data offers a middle ground, being more structured than raw text or images, but more flexible than traditional database records. It's an essential type of data in the modern web and AI applications. Let's turn our attention now to a term that's become a buzzword in the tech world: big data. Picture this, an immense ocean of data, so vast and deep that it's beyond the scope of traditional databases. This is the world of big data, where the data isn't just big, it's colossal in volume, rapid in velocity, diverse in variety, varied in veracity, and rich in value. Imagine dealing with terabytes or even petabytes of data, streaming in every second from social media, sensors, and countless transactions. This is the volume of big data. It's not just about the size, but also about the speed. Data flows in at an astonishing pace, needing immediate processing. And the variety, from crisp numbers in tables to messy, unstructured text and images. Big data encompasses it all. But here's the catch: not all this data is reliable. Ensuring its quality, its veracity, is a significant task. The value of big data lies in what we can extract from it. It's like mining gold from a vast landscape of digital information. But with such great opportunities come formidable challenges. How do we store this colossal amount of data affordably and effectively? How do we process and analyze it swiftly to make timely decisions? And importantly, how do we protect it? In the age of big data, privacy and security concerns are more pressing than ever. In AI, big data is a treasure trove. It's the raw material that, when processed correctly, can lead to groundbreaking AI models, but it demands advanced technologies, from distributed computing to sophisticated machine learning algorithms, to manage its scale and complexity. So big data isn't just a feature of the modern digital landscape. It's a phenomenon that's redefining how we approach data in AI. It's a thrilling yet challenging frontier, promising immense potential but also demanding innovative solutions to harness its true power. Let's bring these data types to life with some real-world examples and use cases. Structured data. Imagine you're shopping online. Every item you see, its price, the category it falls under, the customer reviews, all this is stored as structured data in the retailer's database. It's organized, easy to search, and crucial for the smooth operation of the website. Banks use structured data to keep track of transactions, account details, and customer information, all neatly organized in rows and columns. Unstructured data. Now think about when you upload a photo to a social media platform. This photo is unstructured data. It doesn't fit neatly into a table, but it's full of valuable information that AI can analyze, recognizing faces, interpreting sentiments, or even tagging locations. Similarly, when you send an email or write a document, the text is unstructured data, rich with information that AI can process for language translation, sentiment analysis, or content generation. Semi-structured data. Let's say you're using a fitness app that syncs your workout data with your smartwatch. The data, often in formats like JSON or XML, contains various pieces of information: your heart rate, duration of workout, calories burned, not in a rigid table but in a more flexible structure. This semi-structured data is easier for the app to process than completely unstructured data and more flexible than strictly structured data. Big data. Consider a streaming service recommending movies. It analyzes vast amounts of data: what you've watched, your ratings, viewing habits of millions of other users, to suggest movies you might like. This is big data in action. It's not just the data from your profile, it's the aggregation of massive data sets that are constantly being processed to enhance your experience. In each of these scenarios, the type of data dictates how it's used and the kind of AI solutions that can be applied. From the precision and clarity of structured data to the richness and complexity of unstructured and big data, each plays a unique role in the tapestry of AI applications.